Hello. I was looking around on Banggood and I found this little speech synthesis module. It actually does a reasonably good job and it's not too difficult to use.
Not too bad, eh? So like I say, I was looking around on Banggood, like that thing said. I was looking around on Banggood and I saw this, and this is one of those things that I really have no reason to be buying, but I was just curious about, and it wasn't too expensive considering what it claimed to be doing. I was almost thinking that I might have been mistaken when I read that it was going to synthesize arbitrary speech, which is what it says somewhere down in the description there, but that is indeed exactly what it does. And you'll notice that it also says support encode, decode Chinese and English speech. So apparently it can also do some kind of listening as well and recognizing what you're saying, but I could not get that worked out, and I wasn't really too interested in it anyway, so I'm not going to be looking at that in this video. The main problem was that the documentation's all in Chinese, and the translation that I got from an automated translation was just struggled to understand what the hell it was talking about. So I'm not going to look at that, but I will look at some simple code that you can use to get this thing to talk to you like I just did. So let's just have a quick look at the connections that I've got here. These wires here are unrelated. I'm just reusing this Arduino that I had. This is a 3.3 volt Arduino, by the way. I'm pretty sure you're going to have to use 3.3 volt signals for this, because this thing here is all running at 3.3 volts, and I couldn't find out, or I couldn't see any documentation that said it was 5 volt tolerant on the signal pins. So just to be safe, I would recommend trying 3.3 volts only. So all I have to connect it here is ground, 3.3 volts, and then RX and TX for my UART, and I've put those on pins 7 and 8, so this is going to be a software serial, and this is just running into my computer, and on here I have 3.3 volt selection. The only other connections that are connected are these two wires here, which is for the audio output. These don't have any polarity, obviously. They're just creating waves of sound. And I've got this plugged into a little mixer thing that I use to record my talking when I'm doing these YouTube videos. I could have put this to come out into a loudspeaker and then recorded it into this microphone that I'm using to record my voice, but I figured that people might be curious about exactly what this sounds like, because the quality of audio is something that's probably quite important when you're considering using something like this. So I wanted to record the exact audio that this thing puts out, and it's going to be mixed in with my voice. So you'll see here that there's a little bit of unprotected wiring here, so ideally if you wanted a nice clean audio it would be shielded, but this is not shielded, and we've got about 40 centimeters of wire that's unshielded. So in theory you might be able to get slightly better audio quality than this, but I think it's still not too bad. So the documentation that we're going to be looking at is not actually for this module, it's for just this chip on its own. So to know where to connect each pin, the only place I could find that showed that was on the Banggood listing here, and you can see that they've listed them up here, 1, 2, 3, 4, 5, 6, like that. And these are the pins here, so I've used ground, VCC, RX, TX, and then AOP and AON for my speaker outputs. And you'll also need to make some switches, or make some selection with the switches here to say what baud rate you want to talk to it at. So in the bottom right hand corner of the board there you can see it's labeled baud, and where it says 9600 it's got tick, cross, cross, tick, or that's on, off, on, which is what I've done here, on, off, on, and that will let me talk to it at 9600 baud on my software serial. So jumping right into a very basic sketch, I've got my software serial on pins 7 and 8 because that's what I have it on there. I'm doing serial begin at that speed to talk to the serial monitor, which is here, and then I'm just doing a loop which checks if any information is being given to us from that module, and it's just going to print out each byte and then a new line. So I could actually just do this, couldn't I? Print line like that. Might be a little bit more succinct. And you'll notice I'm using the hexadecimal format. That just makes it easier to match up what we see here with what we see in the documentation. So if I upload that now, we'll just get no output because we haven't actually told the module to do anything. But let's have a look at the documentation now. This is the documentation that was linked to on the Banggood page, and like I said, unfortunately it's all in Chinese, so I couldn't really make a hell of a lot of use of this. So I used an automated translation software that translates PDFs and retains most of the formatting. It's not that great, especially when you get down to some of this other stuff where the formatting is like this with tables within table cells. It sort of gets a bit funny after that, but for the most part it's not too bad. The first part of the documentation is all about the details of I2C speeds and all that kind of stuff, but it gets good at about 7.2, around about here. So gets good meaning that it's something that we can actually use with Arduino and do something with. So there's a few return codes that it has, and these are the hexadecimal codes for these. So when it starts up, it'll say 4A, and I've never actually seen that because usually I'm starting my Arduino and this module together. But if for some reason you had powered your Arduino up and your Arduino was listening for output from this module and then you powered this module up, I think you would see a 4A coming up at that point. 4.1 means that it has correctly received the command that you told it to do. And let's go to the next page. We'll see 4E means it's busy, and 4F means it's idle. And this last one is quite important, and it's mainly only because of this last one that I'm showing you this particular table, because this will let you know when the speech that it's saying has finished, and then you can tell it to do something else. If you tell it to do 2 or 3 things all at the same time, you'll only get the last one done, because it just quits doing whatever the other ones were when you tell it another one to do. So if you want to say things in sequence, you're going to have to listen for this 4F byte. Alright, so what are the commands that we can give it? I'm only really going to look at one command in this video. Oh, actually 2. You might want to just do this status command to check that your connection is alive and the module is not faulty or something like that. So the way things work in this system is you have this FD, which seems to be the beginning of a command every time. Then you'll have a 16-bit integer, or a 2-byte integer, and you have a high byte for that and a low byte. And this will be the size of the rest of the message. So in this case, in this example, we have just a 1, which means that the rest of the message is only 1 byte long. And then the data area, or the content of the message, is here. It's just this 1 byte, which is a 21. And 21, or it's not 21, it's hexadecimal 2.1, is a command saying to get the current status of the module. So let's put these 4 bytes into the serial connection. I'm just going to copy them from over here because I've already done this earlier. And get rid of that. So if we put this in here, so we've got FD 0121, and I've qualified this as an unsigned character here because if you don't do that, it says it's ambiguous whether you want it to be an integer or a float or something like that. I'm not sure. Actually, in in Arduino parlance, this would be a little bit more suitable as a byte, wouldn't it? I think that should work. So when we do this now, we are just asking for the status of this module, and we just want to check that it's alive. So we should see, I think it was 4.1, was it? 4F. Hold on a second. Was it 4F? Oh yeah, okay, 4F means that it's idle. It's not doing anything. Good. So there's a few other things you can do at the upper levels. You can tell it to go in and out of power saving mode and so on. But I'm just want to skip straight to the voice synthesis commands, which are in the same format. So it's always FD as the beginning of the message. Then you've got the 2 bytes for the length, and then you've got the data itself. And I'll just skip straight to an example. The command that we're going to give this time is 01, speech synthesis command. You can also tell it to stop, pause, keep going. 2.1 is the one that we just did. So this is the status inquiry. if you want to see what it's doing at the moment. But let's just get to this command 1, which is what it's all about. Now this is this is where the tables start to fall apart in their format. But the way it works here is you have the header, 2 bytes in green for the size of the rest of the message. Then the data area is going to be the command, so that's a 1 to say that we want it to talk. Then the next 2 bytes are going to be, the next 1 byte is going to be this here, which is the text encoding format, and it's going to be a number between 0 to 3, and you can specify what text format that you want to give your text in. And I've found that for English this one here is by far the easiest to use. I tried doing it in Unicode to start with, but boy, that was an uphill battle, so I just went straight back to using this, and that works great because you can just type your text directly into your sketch and it will read it right off there. But let's look at one of the examples here, and I'll just switch over to the Chinese one here because it's a hell of a lot easier to read. Alright, this is what I wanted to look at here. So this is what that table that we saw before should look like instead of being all squashed and messed around. So you've got the header, the size, and in this example here you'll see that the size is 10 bytes, and then that means that everything after here should be 10 bytes. So then we've got this one in pale pink, which is the command type, which is speak. Then yellow again was the type of text that you're going to be giving it, and then you've got the text itself following. So because we've put 2 bytes here and we're saying that it's 10 long, it's expecting another 8 bytes of actual text there, like this. If you don't give it enough, it's just going to sit there and wait forever. So you need to give it as many bytes as you told it you were going to give it there. So let's go back to the sketch. So instead of command 21, we're going to be giving it command 1. And oops, I've forgotten to do something here too. I'll just put this, comment this as size, so it's going to be A. So it's 10, and then we've got, hang on, getting a bit confused, hold on. Let me comment this. Command type, and this is going to be text format. And then we've got 8 bytes of the actual message. Yeah, that's right, so there's 10 bytes there. Alright, let's run that. Alright, so we got a 41. Now the 41 tells us that the command that we sent was received correctly. And then a little bit after that we got a 4F, which tells us that the text that we told it to speak has finished speaking and now it's idle. And we can tell it to do something else. So I'm not exactly sure what it said, but these 8 bytes here will be 4 Chinese characters. Actually, I think if we look in here, it says it'll be this. Whatever that says there is what it said. Something about flying, I think. Big flying, I don't know. Anyway, so you can see that that's all it takes to get this thing to do some simple talking. Now, of course, you want this to be in English, right? Well, I'm assuming most people watching this video do at least. So what we can do, now, provided you're using this GB2312 encoding, so that's 0 in that byte, you can put in some text here that's the same. I'm just going to put in something that's 8 bytes long, and I'll just comment out that Chinese one and run that, and with a bit of luck,
overload.
Now I say with a bit of luck because sometimes it doesn't quite get this right, and the way it's working is it's trying to automatically determine whether you're giving it Chinese or English, among other things. So it's trying to figure out all kinds of different formats as well. So if you give it the text that says like 1, 2, 3, it'll say 123, maybe, depending on what formats you're using. And if you give it km, it might say kilometers instead of km or something. So it has quite a bit of work to do to figure out what you want. It doesn't always get it right, but we can, if we go all the way down to, it's way down here I think. So you can put these little pieces into the text to guide it into the formatting or the pronunciations that you want. And I'm just showing you this in the Chinese one first because notice that these are lowercase. They're all lowercase. But when we look at my automatically translated English version, we'll see that they're showing in uppercase here. So, oh, that one's in lowercase. But just keep in mind that if you use this, I'll put a link to this in the description if you want to use this automatically generated translated PDF, but just keep in mind that these should be lowercase. Anyway, so it's text control, list of tags, and as it says up here, you just put it into square brackets like that to change them. And if you are only ever going to be using English, you might want to put in a G2. So see if we can do that. So that would be like this. G2, like that. Now this is not going to work. I'll just run this and show you what you get from that.
OH.
Now this didn't work because has anybody noticed why it didn't work already, by the way? Let me know in the comments if you're smart enough to figure it out. But we need to now just say that the size is no longer 10 bytes total. It's actually, we've added 4 bytes here. So what it is a lot easier to do is put your string, you do something like this. Put your string in there like that and use it as a variable. Oh, and then we're going to have to put this up here, aren't we? Oh no, right up the top. If we put this up here, then we can do the size of the total content is going to be 2 plus whatever the length of that message is. So now I think we should get the whole oh hello. No? Oh, I see the problem. It's just the typo here. I put a multiply instead of a plus here. Somebody's probably yelling at their screen out there. Well, I guess that serves as a demonstration of what happens when you don't give it enough bytes in the content to complete the expected number of bytes that it was waiting for. So let's try that again.
Oh, hello.
And now we can just type whatever we want in here and run it. So this makes things a lot easier.
Oh, hello. Now we can just type whatever we want in here.
Alright, so let's have a look at some of these other ones. Actually, I don't think I'll really look at too many of them. This one here is interesting. So you've got M and then either a 3, 51, 52, 53, 54 or 55. This one here, Donald, I think is supposed to be Donald Duck. Let's try it, 54. So that's going to be M54.
Overload. Now we can just type whatever we want in here.
55 is a girl's sound. So let's make it girl's sound, and we'll also change the speed. So S is speed, T is tone, V is volume. Some of the others are a little bit confusing, but let's just try speed. Speed's from, I think it's from 1 to 9, so let's make it quite fast. Tone will make it quite high pitched. It's going to be higher pitched anyway because we're changing from Donald Duck to a girl's voice. I think it should be quite high, so let's make it really high, tone 8. Volume is about right, but let's make it a little bit louder. So I think it's 5 already, so let's make it slightly louder.
Overload. Now we can just type whatever we want in here.
And I'll make tone really low and compare it.
Overload. Now we can just type whatever we want in
So
here.
that sounds like the Donald one again, doesn't it? And if we make speed really low, just put these back to the middle.
Overload.
Hmm.
Now we can just type whatever we want in here.
Reminds me of somebody I used to work with. Right, so there's a few other things. Maybe just one other thing. Let's just see what it does. I drove 123 kilometers.
I drove 123 kilometers.
Kilometers, okay. Now, if you didn't want it to say the whole 123 as a word, I think it's N for numbers. So setting the digital processing policy. Most of these start out as automatically determined, by the way. So if you wanted for the number, see, a lot of this English translation just doesn't really make sense, does it? Let's try what we get with N1.
I drove 123 kilometers.
Okay, and N2.
I drove 123 kilometers.
Maybe it wasn't that one. See, this is what I was saying about the documentation being really hard to follow. Was it X? I don't know. But there is one of these tags you can get it to say 123 kilometers. What does it do here?
I drove 123.
Oh well, you can figure that out just by playing around with these tags, I guess. So they're all listed there. That's about it, really. One other thing that I'll show you that I will upload to my website as a sketch that you can get. Let me just put this here. And that is this quite handy wait for speech function. And so I've set this up so that I can get it to say something. So I've put the code that we just looked at into a function of its own called speak, which is up here. It's basically just what we just looked at, except it takes that as a parameter. And then wait for speech will keep watching the output here until it sees a 4F, and then it will continue. So that lets it do something like this. So we've got speak message 0, wait for speech, speak message 1, wait for speech, and then just stop. So message 0 is what we heard right at the beginning of this video. I was looking around on Banggood. And then message 1 starts off with an X1, which is... Oh, now I remember what that tone was. Alright, so we have X. X0 is do not use tone. X1 is do use tone. And somewhere further down in the documentation, I forget exactly where, you'll see a list of these things here. So sound 104, sound 105. I'll play them in a minute so you can hear what they sound like. But if you have X set to 1 like this, it's going to play a sound instead of reading this as the word sound 104. But if you have it on 0, it will read this as a word. So that first message is a little bit long, so I'll just make it shorter. Maybe not quite that short. Let's stop it there. Alright, so I have a bunch of things in here that's going to change the voice and the tone and the speed of everything. And then after that we'll just hear those sounds. And it should play both of them because we're going to wait in between instead of just starting the next message immediately. And then it should stop and do nothing at that point. So let's run that.
Hello. I was looking around on Banggood.
And there's actually about 30 of those sounds. I just put a handful of them in here. Don't they sound a lot like the Windows sounds? I wonder where they got those little jingles from. Yeah, so that's about it for this video. It's probably a little bit longer than it needed to be, but I just thought I'd have a look at this because it could be quite useful for something where you wanted audio feedback. Audio feedback can be quite detailed, so it's not just turning an LED on and off, and it's better in some applications than using one of those little OLED screens because you don't have to keep looking at it all the time. You can just have something running, battery charging or something like that, I don't know, and you don't have to keep looking at it, and it will just tell you when it's ready. And one other thing, I know, just before I finish up, I know I'm going to get people asking about how do they put, for example, drove, and then you want a variable number of kilometers in there, something. So let me just prepare one last example that has a sort of a dynamic piece of text, and then I'll finish this video. Actually, it won't take very long to do that right now, so let me just put it in here. The reason I'm going to do this is because I seem to get a lot of questions from people who are not very familiar with C in general, or C++. So you need a character buffer of at least as long as the number of bytes that are going to be in your message, and then you'll have you use this function called sprintf, very easy to look up online, and you're going to put that into this buffer, and then the text is going to be I drove, and then this will give you an integer, and then we're going to have kilometers after that, for example. Let's make it a little bit more appropriate to something that you might actually use. Battery is, and I'm going to put a percent here. I'm not exactly sure what it's going to do. Hopefully it will read that as percent. Alright, so let's say that's your message, and then you want to replace that %d with 87, for example. So this 87 number here, if you were writing a real battery charger application, this number would be coming from the sensor that reads what the battery is at. So that's how you make a dynamic string, and then we would do this kind of thing again, like that. So we're going to be speaking this buff, and just to make sure, I'm pretty sure we've got 32 characters there, but whatever that is, yeah. Right, so unless I've made a mistake, that should say battery is 87% charged.
Hello. I was looking around Banggood.
Oh, did I? How I got rid of that. Let's try again.
Hello. I drove %dkm. Battery is 87 charged.
Alright, so I guess in some cases it doesn't know what to do. So you might just have to give it the actual word. Oh, let's just get rid of these.
Battery is 87% charged.
There you go. Alright, so I think we can finish this video now. So I'll put this sketch, simple as it is, up for download on my site if you want to get a hold of it. And hope that was interesting. Thanks for watching.